Hello and welcome to the West Coast Informatics tutorial on our reference deployment, wci.terminology.tools. This is going to be a quick session to go over some of the features of our terminology server browser environment in the context of a variety of different terminologies. So the first thing is go here to wci.terminology.tools and it will load the landing page. There's a brief description of what's loaded in here and where it comes from. This page also describes some various features of the tool with screenshots that you can have a look through so you get a sense of the overall capabilities and links to the online documentation. To begin using the tool, click Start Browsing. So this takes you to the login page. There's two ways to log into this tool. One is via UMLS UTS login. So the information in the server comes from the UMLS, which is a database produced by the National Library of Medicine here in the US and licensed through their own service. So we're a essentially content redistributor and allow you to log in using your UTS account, or you can request a 30-day access token from us at info@westcoastinformatics.com. That information is right here. And then we'll send you back a token, which you can paste in here and log in with that token, and it's good for 30 days of use. Just to show how the UTS login works, I'm going to do this mode here. So you click on this button and it uses the single sign-on mechanism of the UTS system. I have Google, so use my West Coast Informatics account here. Redirects me back, and then it'll send me back to the application itself. And now I'm logged in. So here you can see on the terminology tab that there's a number of terminologies loaded into this environment. Each of these buttons is a terminology, and if you click on it, it loads that terminology, sort of it points the browser at the content for that terminology. So we'll start here with SNOMED. So there's kind of 5 things here we'll take a look at. The first one is metadata. So each terminology has a collection of metadata that comes with it, and this is just a place for providing more information about things like the name of the source and the version, and in this case it's FHIR URI or OID. And then we've got lots of metadata about languages and term types and relationship types and other things. So every terminology has its own perspective into the metadata. This is really useful if you are particularly interested in how terminology metadata works, but otherwise probably isn't a tab that you need to use. Next, we have the subsets tab. So in here, we essentially have all the rough sets of SNOMED loaded in, including the standard ones and other ones that were distributed separately by the National Library of Medicine. Here, there's actually a couple pages of these. So we could see here, there's also the core problem list subset. And if we click on one of these, let's say the route of administration set, then below you'll see that it loads the list of members. This is searchable. It has the semantic types. And you can actually click this little icon here and it will export this subset for use externally as a tab separated values file. Clicking on this link here also will cause this concept to be loaded into the section below, which we're going to have a look at in a little bit, but that way you can actually see all of the concepts that are involved. So that's a quick look at subsets. The next section we have here is maps. And so these are mapping sets. In this case, SNOMED comes, this is the SNOMED US edition that comes prepackaged with the mappings to ICD-10-CM. So here's what the mapping display looks like. Clicking on this shows there's 221,193 maps. We can page through these or also perform sorts. So for example, you could search for something and it'll restrict to just the maps that involve that, or a code if you wanted to do it that way, to see individual maps. And like before, if you click on either of these things, you get the corresponding concept loaded below. So here, if I click on the SNOMED concept, it loads as hypercapnia, or if I load this J96.01 in ICD-10, it'll load the concept view for that thing as well. So you can kind of go in and have a look at a little bit more information. Again, other terminologies may have other mapping sets and other subsets. This is just the view of what's contained for SNOMED. Then we get down here to the content section. So on the left, we have a search panel, and we can just sort of search for something. It performs a search according to an algorithm that's really intended to drive best results for a user of the browser. There are some other searching algorithms that are possible here, but we're not going to really get into what those do differently. Few other features of this, the autocomplete button, if you check it, then as you're typing here, it comes up with other possible suggestions of what you might want to search for. And if you pick one of these, it completes that search. But it's turn offable because sometimes it's not something you're interested in using. Additionally, so if we search here, you can see that it's searching among only active concepts. So if we want to include inactive stuff, we can turn that off, and you'll see inactives show up sort of grayed out like this one here. So that's another thing. And you can also search for matches among only leaf node concepts. So here, leaf node meaning the results will not have any children in the tree. So it'll only find things that are at the bottom of the tree. There are certain use cases for which that's very useful. So coming back here, there's a couple other things I wanted to point out. So in the semantic types here in the report on the right, which we'll go into a little more detail in a second, there is this type disorder. So we can constrain searches by this expression or semantic type field here. So if I put disorder in here, then what this will do is only search among things that in SNOMED are tagged as disorders. And a kind of another way that we could do that is via a SNOMED ECL expression. So for example, if we only wanted to look under malignant neoplastic disease, then we could use a SNOMED expression, ECL expression, and search within this also. And then we're only finding descendants or self of this concept that are matching melanoma. And I'm putting this in here with the name in it so it's easier to see. This is ECL syntax, but you can have this out of there as well, and it performs the same search. So this is a useful feature because it allows you to constrain the search in a variety of ways, both programmatically and through the browser itself. All of the calls that you see here are backed by the API, and you can go have a look at the Swagger documentation if you're interested after the fact. So here we are on malignant melanoma. Let's take a look at this report on the right-hand side. So few key things here at the top is the terminology, the code or concept ID in this case, and the preferred name. So the computation is undertaken. In this case, it resolves to the preferred name in the US language reference set for SNOMED, and that's the calculation of how this name gets chosen among all of the other synonyms, which we'll look at down here. So here we have semantic types. So these are in sort of the semantic tags in the context of SNOMED, but in other terminologies will be semantic types from the UMLS or other places. Next, we have hierarchies. This shows essentially the position of this concept in the tree in SNOMED. Because SNOMED can have concepts with multiple parents, it's possible to have more than one tree position. So this view lets you essentially cycle through the different tree positions so you can see what's going on. Sometimes there's very, very many of them. And also, this provides you really access to the entire SNOMED tree. So here, this parent has many children, including the one that we're on, but it's only loading 10 to make this display reasonable. You can click this link here and have it actually load more of them, or if you really want to see them all, you can do that. And then, of course, you can collapse these nodes and then expand other parts of the tree to pick up the additional children at that level. And really, you can browse the entire hierarchy here. If you click on any of these links, it'll load the corresponding concept instead of the one that we're looking at. So this is a nice feature for really probing the full context of where this data lives in whatever terminology we're having a look at. You can also click on this header and it collapses it in case it's too much information and you're not interested. Next, we have just some properties or top-level attributes. Each terminology kind of has its own way of representing this stuff, or the way in which it's loaded has it represented in a certain way. And then we have the descriptions in SNOMED. This label atoms is used just so that there's a consistent label, in this case, across all the different terminologies. But these are all the different names for this thing. You'll see some of these come from SNOMED, like the SY and the PT and the fully specified name here. And then all of these ones called index SY are actually generated synonyms or included synonyms. So part of what we've done in this environment is show that we can augment the content by including a variety of synonyms from other content sources. We can load synonyms from other resources like the UMLS or manually curated synonyms or other generated synonyms for one reason or another. So there's a lot of capability to augment search and enable more sophisticated ability to find things through all the variability of how naming might happen. And they're called index SY to keep them sort of separated from the real content. Next, we have this kind of reverse view of the subsets tab from above, which lets you say, find all of the members that belong to a particular set. Here we reverse that and say, find all of the sets that I belong to. So in this case, this concept is a member of 5 different SNOMED ref sets, and the names are here. You could take these IDs and go look them up to, find more information in the subsets area above. Next, we show any mapping. So this concept does have an ICD-10 mapping here to C43.9. Clicking on this would actually load that concept into the display here. So you can really see kind of the full context of everything. And then finally, we have the relationships. These are the defining, in the OWL, the defining sort of object and data type properties that represent the definition of the concept as originating from that concept, and inverse relationships are essentially the things pointing in the other direction. So these are this concept is a child of these two things here. It is a malignant neoplastic disease, and then the inverses down here are essentially the children. So this is a parent, this concept we're on is a parent of this concept here. And the nature of the relationship is inverse if you want to see all of these, you can expand the page size here and then but it looks like there's nothing else in this example other than child concepts, no additional relationships. But were you to look at, let's say, a morphology concept, you would find that it has a lot of inverse relationships because it has, oh, actually, I might be wrong about that. So never mind. Okay. So that's a quick look at that. There's a few other little features here that I wanted to go over. But first, we'll take a quick look at another terminology. So that was SNOMED. In ArcSNORM, we have a drug terminology. Oops, I mistyped that. I just wanted to say aspirin. So here we've got a lot of synonym generation for aspirin based off the UMLS and other resources. And you can kind of effectively walk the graph of the ArcSNORM concepts by following the various relationships, which you can also sort of filter by. So here we want a has trade name, so we can follow and say Solprin is a trade name of aspirin in the US in this case, although this is actually inactive. So that one's not terribly interesting. And so, for example, here, like a sort of more fully realized drug case, we can see all of the ways that it points out into the other model. So, there are other tools within the API here that let you kind of walk these graphs of objects in particular cases and build a model that represents the full content of something like a drug. It's beyond the scope of this demonstration, but things like that are capable of being done here. And of course, you have all the other same range of search features. A few other little quick things to point out. You can click this little icon here and it'll open this in a new window so that you can sort of compare things side by side. We've got a little bit of a concept history mechanism so you can see the recent stuff you've been working on and just sort of jump back to it. And then similarly in the search case, we can also do a similar thing and look back through the recent history of searches and go back and research something that we had been looking at before, as well as like on the subsets tab, the ability to download all the content. You can do that here too. This downloads the tab separated values file of all, in this case, 576 search results into a file. So if you're interested in kind of looking deeper into what these things are, and in particular, you can craft searches that have targeted sets of things. So in fact, you could do things like we had the melanoma case. If you really wanted to see all of the descendants of malignant neoplastic disease, you could put this expression in here. And then you could download, this is get rid of melanoma even, so it'd really be all of the descendants. And you could download this list of 5,000 things. As a set, and it represents the complete set of descendants in this case. I do want to point out just really quickly at the end here too that you can also search with nothing. I always like the idea that you should just be able to come in and just say, show me some content, whatever it is, I don't care, anything. And it's just sort of like whatever happens. So this resolves to essentially everything in this case that's active only in SNOMED. So I don't recommend downloading this entire thing. You'll kill our server, so please don't do that. We're not blocking anybody from doing that at the moment, since this is just a reference deployment and not intended for any kind of production use. Just quickly, I did show there's this config section at the end. There's a variety of config information that lives in here. It's really here primarily just for reference and debugging, so we can sort of see some of the configuration aspects of what drive the tool. But it's probably not useful from a perspective of someone who's interested in the terminology content. All right, that's just a quick overview of our reference deployment at wci.terminology.tools. Please email us if you're interested in getting a 30-day token, and we'd love to hear your feedback. Thank you very much.